Okay, there's some stuff that we should probably talk about with coordinate axes before we start looking at different graphs. And one of them is we need to talk about the names of the axes. Obviously, we know this one is the x-axis and this one is the y-axis. But they also go alphabetically. This is called the abscissa. And this is called the ordinate. Remember, they go alphabetically, so A goes before O. And also when we list the points, X is before Y. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Now, those are pretty important things, but equally important is that you need to know what kind of signs you've got, because both of them are positive in the first quadrant, because this is positive and this is negative. This is positive and this is negative. So if you go over here to the second quadrant, the first number is negative because you're going back. The second number is still positive because you're going up. In the third quadrant, they're both negative because you're going back and down both. The fourth quadrant, you're going forward, so it's positive, and then you're going down, that's negative. So you can see where the quadrants are and what the letters that go with each of those quadrants. And I think that's an important thing. Now, the other thing that's probably important to note is that if you have a point like this one right here, which is, I think, negative 8, positive 4, is that if you go a vertical line through here, all of these points will be negative 8. Doesn't matter where, some of them will be up here, might be negative 8, positive 10, and this one might be negative 8, negative 15, something like that. And then the other thing that's true is as you go across, these points all have a positive y coordinate. Doesn't matter what the x coordinate was. Over here it might be positive 11, 4, and so on. So that's something that it's important to note. All right, so one of the things that we can do is we can find out what the coordinates of certain points are. Like, for instance, if you look here, we've got some points that we can find their coordinates. Let's take this point right here. If you notice, we always do this axis first and then this axis second. So we're going to go over first, and we go over to 6. And so our first coordinate is 6, and our second coordinate is 9. Or in this case, we go forward 3, and then from there we go down 8, and so it's negative 8. Now that would be something that we could do, but there's other things that we can do that are probably a little bit more, I don't know, fun, let's say, than that. Let's take a look at how we can use our graph to determine what the solution of a system is, just because we can just go by what is the coordinates of this point right here. Well, we go forward 3 and we go down 1. So that's one way that we can do it. Let's look at another example. Let's look at this one right here. So on this one, what are the coordinates of the spot where they cross? So I put that dot there just to help me see what they are, and we go forward 3, and from there we go down 4, so it's over 3, down 4. So that's another way that we can do it. I think there's some more examples that I've got here. This one is a little tricky because I need to show you that it says this is the number of detectors in thousands. So remember, this is 1,000, 2,000, and so on. And then the price is in dollars. So we do have that as the intersecting point, which would be 1, comma, 40. And I suppose I would probably give you a partial credit for that. But remember, it's in thousands. So we should really write that as 1,000. So we have 1,000 smoke detectors sold if the price is $40. Let's see if we've got another one. Here we go, the price of cars. That would be another one that we would look at. Price of cars in thousands, number of cars in thousands. So here we've got 6,000 cars sold when the price is 25,000. Thousand. I think you did examples like this if you ever took economics. They would have examples like this one. Let's see if there's any more. Nope, no more like that one. But this is the one that I think is most interesting. It looks a little scary because you see the graph here. And let's say that somebody wanted you to do something like this. Let's say they wanted you to find when the time is 2.5 hours. Well, you would just go over here. Here's 6 hours. Here's 3 hours. So 2.5 hours would be right here. And you would go up. And so your dot would be right there. And so we would say 2.5. That's our first coordinate. And at 2.5 hours, the temperature appears to be, I don't know, 59 degrees. You can get close to what it is. And so you can see that the temperature varies as the time because, of course, the sun will warm up the sky. Let's see if we can find another one that's similar to that. The number of amount of daylight throughout a year. So we want to know how much daylight is there on the 54th day. Okay, so we're going to go to day number 54. Well, here's day 60. So 54 would be around here. And then we go up, and our dot will be right around there. So at 54 days, our time is a little bit less than 11 hours, say 10 hours, and, well, here's 30 minutes right here. So maybe 10 hours and 50 minutes. I don't know, something like that. Let's do a couple more of those just because I think they're a little bit tough to do. Let's look at this one. Here's the height of the tide and the time. Actually, I have that. I should say the time is in hours, isn't it? Okay. So, if you notice here, we've got, let's do this one. Oops. Let's do this first one here, where we're going to find the time of the tide. Okay, I got to get it off yellow. That's all I'm trying to do. Sorry about that. Okay. So we're going to see at 19 hours. So I'm going to get the graph here. We're going to get at 19 hours. Well, here's 18. Here's 21. So 19 would be about here because 20 is about here. So at 19 hours, it appears as though it's almost 5 feet. So in other words, it's almost at a high tide at 19 hours. I want to do one more just because I think it's important for you to be able to just look at a graph and figure out what it's saying. Here's a graph of a pendulum swinging compared to its time. And in this case, we're looking for where is the pendulum at 2.8 seconds. Well, 2.8 would be right about here. So at 2.8 seconds, oops, sorry about that, 2.8 seconds, the pendulum appears to be about I don't know, 0.8 meters. If you notice, here's the meters axis, so I'm kind of guessing a little bit, and sometimes you do have to when you are graphing. So that's a very important characteristic that you need to do. There's one more thing that I'd like to show you that will help you with your graphing problems, and that is like numbers 13 through 16, where you're supposed to graph and then figure out what kind of shape you have. Let's do number 14. So on number 14, you go over 2, down a half. Tell you what, I'm going to make each box worth 2 boxes is 1 number in each direction. So I'm going to go forward 4 boxes, so there's 1. So that's equivalent to 2, and then go down 1, go forward 3, and down 1.5. So here's a half, here's 1, here's 1.5. Go forward 1.5 and down 3, 1, 2, 3. So we're at this spot right here, and go forward 1/2 and down 2. And if you look at our shape here, it appears as though our shape is something of a rectangle. So that should help you do those 13 through 17 numbers. On the next page, it asks you to graph numbers and then give their coordinates with an ordered pair. Now you can do it just like we did this one, but I would rather you try something different. I know you may not like to do this, but we'll see how much work it is for you. But let's look at number 19, excuse me. So for number 19, here's my x's and here's my y's. So my x is -3, that matches with -2. 9 matches with 6. 3 matches with 2. -6 matches with -4. So I'm going to graph those, and here's how I'm going to do it. Okay, I've got my x and my y, and then I'm going to insert a scatter plot. And if you notice, I can even connect them with a line. Let's see which one to add. It looks like it's a straight line, so I'm going to use the straight line one, linear. Looks okay. And there it is. They are connected with the graph. Let's do number 21 also. Okay, so number 21. Here's the x and the y. Now the reason why I like this better than the graphing calculator is that you can more easily see your mistakes using Excel than you can with the graphing calculator. And when you get out into the working world, there's going to be a lot more work with computer programs than there is with graphing calculators. You probably won't use a graphing calculator much after our class. Now, the other thing is I'm not so sure how many of you even have graphing calculators, because it's not a requirement that you have graphing calculators for this course. So let's insert a graph again, a scatter plot, and let's see here. If you notice, we've got a line going this way and then a line going that way. I think you might even say it's a double line, huh? You can see a line going in each direction. So it goes down until you get to -4, and then it goes up, but not quite as steep on the upward section. So it's sloping down, and then we would say it's sloping up here towards the end. So those are how you would do these kinds of problems, and I hope this video helps you.